Now we're going to look at an example involving a mass in a lift, and the lift is not only moving but accelerating in a downwards direction. Now this may involve the lift moving upwards or downwards. The direction of travel is not important. The direction of acceleration is. A 60 kilogram block is in a lift which is accelerating downwards uniformly, which means at a constant rate of 2.5 meters per second squared as shown below. Now as the lift accelerates downwards, the net force on the 60 kilogram block, which also accelerates downwards, must necessarily be downwards. This means that the two forces which are usually acting on the block, that is the normal reaction up and the weight down, are no longer in balance. Indeed, the weight has to be larger in size than the normal reaction in order to achieve a net force downwards to create this acceleration. So the first question asks us to calculate the magnitude of the weight acting on the block. This is in fact a function of the Earth's gravitational field strength and is independent of the motion of the block at any time. It is simply given by weight equals mass times gravitational field strength. 60 times 10 or 600 newtons. The second question is the magnitude of the normal reaction, which is sometimes referred to as apparent weight acting on the block. Now we'll get back to apparent weight later, but it's a way of us recording how it feels when a force is acting on us, and all we can feel if we're standing on a surface is the surface pushing upwards on us, and that's why we call that the apparent weight. However, it's only equal to the actual weight in magnitude in the instance when you are not accelerating. Since if you are accelerating, some of the weight is used to accelerate you. So to do this question, we need to consider just the 60 kilogram mass once again and the two forces acting on it, weight down and normal reaction up. And although shown here it looks like the normal reaction is larger, indeed the opposite is true, since the net force must be down to create a downwards acceleration. Taking downwards as positive, weight down minus normal reaction up must equal mass 60 times acceleration. The acceleration is given as 2.5 in a positive direction downwards. Therefore 600 being the weight, which we previously calculated, minus the normal reaction has to equal 60 times 2.5, which is 150. Therefore that leaves a normal reaction of 450 newtons upwards. 450 up, 600 down, the net force is 150 newtons needed to accelerate the 60 kilogram mass at 2.5 meters per second squared.